In this video, I'm going to explain this example, which is actually very simple, but I'm going to use this case only to introduce the critical point that you were surely asking, what about this saddle point? So let's get to this idea, and on the way we'll figure out what a saddle point is. So I'm going to start doing the same, looking for critical points. That will be to take the derivative first. To take the derivative, so it will be f prime of x would be in this case equal to 3 times x squared, which is the derivative of x to the third. And then I'm going to equalize this derivative, just like what we got here in this statement, to equalize it to 0. 0 equal to 3 times x squared. Now I'm going to solve for x, for this expression. I'm going to solve for x. So we divide both sides by 3. We got the 0. It's equal to x squared. Now we can take the square root from both sides. We actually get the one and only critical point, which is x equal to 0. X equal to 0. Now, yeah, we got this guy, x equal to 0. Well, let's figure out whether if it's a maximum, minimum saddle point. Of course, it's going to be a saddle point, but it's still got to figure it out. So I'm going to locate here our sole and only critical point, and I'm going to pick a value before and after this guy. So I'm going to pick first the f equal to, let's say, the negative 1. The negative 1 to evaluate on the derivative, So we're going to evaluate on here on this derivative, and this would be equal to 3 times the negative 1 squared. And we got at the end that this would be, of course, a 3 times 1 would be a 3, which is, of course, a positive value, which is implying that this would be ascending. Ascending. Okay. Now let's pick another value after the 0. Let's say f prime. I'm going to pick f prime of 1. Why not? It'll be 3 times 1 squared, and this will provide us as well with a positive 3, which will be implying, of course, that after the 0 the function will be as well ascending. So this is funny because we got a function that is ascending and then it's ascending as well. So, well, actually that's the main key about the saddle point. You may remember from a maxima, I'm going to write up here. So a maxima, you will identify the maxima because you will have a function that will be ascending and then descending. It will be positive and then a negative slope, or result out of this kind of testing. If you got a minima, you will have the other way around. You will have something will be descending or a negative outcome, a negative sign up here on this kind of testing, and then you will have positive one. So you will go from negative to positive, and so this will be the minima. What about the saddle point? The saddle point actually has two possibilities. The saddle point, you will have something pretty as like this case, which is something that is ascending, and then say it stops for a moment and then keeps ascending. So you got a positive slope, and then after it you still get a positive one. This is the case for this function f of x to the third. If you actually remember the formula, the graph for this x to the third, well, the formula pretty much looks like this. The graph. You will have something pretty much like this, and the graph will look something like this. Will be growing up, then we'll get to the 0, and then we'll keep growing. So this is the graph for this f of x equal to x to the third, and you can see this is pretty much what happens. This is a perfect example for a saddle point actually, but there is another possibility. What about instead of having positive x to the third, what if we would have a negative x to the third? In this case, with a negative sign, the negative sign would have shown the graph to be like this. See, well, that's pretty ugly, but you get the idea, right? And that's the other scenario for the saddle point. You may have as well something is descending, would stop for a moment at a critical point, but it will not be a maximum or a minima, because then it will keep descending. You wouldn't have a change on the sign of the slope. In the other two cases, you have a switch from positive to negative, and then from negative to positive. In this case, the saddle point, you go to positive and then again another positive, or a negative and then again a negative. And that's pretty much the idea for the saddle point.